everyone, welcome back to my channel. My name is Soumya. In today's video, I'll be showing how you can complete this DevOps workflow in Google Cloud Challenge Lab. So let's click on Start Lab. Okay, now the lab is started. Now click on Open Google Cloud Console. Copy password. So here, click on Terms of Service. Click on Agree and Continue. So let's click on Challenge Scenario. So you, as a recent hire as a DevOps engineer for Kimball Superstore, a few months ago, you have learned the ins and outs of how the company operates its e-commerce website. Specifically, the DevOps team is working on a large-scale CI/CD pipeline that they would like your assistance with building. This allows the company to help developers automate tasks, collaborate more effectively with other teams, and release software more frequently and reliably. Your experience with cloud source repositories, artifact registry, Docker, and cloud build is going to be a large help since Symbol Superstore would like to use all native Google Cloud services for their pipeline. Before you start this project, the DevOps team would like you to demonstrate your new skills. As part of this demonstration, they have a list of tasks they would like to see you do in an allotted period of time in a sandbox environment. So in this lab, first we will be creating a GKE cluster. They have already provided the configuration, so we will be making use of that configuration to create this GKE cluster. Next, we'll be creating a Google source repository to host this Go application code. Post that, we'll be creating a cloud build triggers that will help in deploying a production and development application. Then we will push updates to the application and we will create a new builds. Finally, we will be rolling back the production application to the previous version. So this is the challenge scenario. So let's proceed with the task 1, create the lab resources. In this section, we will initialize the Google Cloud project for the demo environment. So first we need to enable few of the APIs which is required for this. So here they have already provided this command. So this will, by executing this command, it will enable APIs for GKE, Cloud Build and Cloud Source Repository. So these are the services name. So this is a container API, this is a Cloud Build API and Source Repo API. So we have to enable these APIs. So you can click on this. Here you can go back. You can do this using this APIs and services as well. On a console, if you click here, click on Enabled API and Services. So here as well you can enable from the console. So you can click on Enable API and Services. So here you can search for that API. So when you can just provide the name of that API and you can click here Cloud Build API. Click on this API. So this is already enabled. So this is one way in which you can go to the API library and search for the specific API and enable that. Another way is via Cloud Shell. So you can click on Activate Cloud Shell. Okay, now this is up. So you can go back to the task, copy this entire thing and paste it here. Now you can execute it. So let's execute this command gcloud auth login. So usually we don't get this issue because we authenticate this when we are enabling the cloud shell. But if you face this issue, then again you can go to this URL and sign in with the student username and the password which is provided in the lab. So once that is done, you will get this. So you can copy this code and enter you. So this is the verification code which we get in the browser. So you can click you. You are now logged in as a student. Your current project is this. So you can change the setting by running. So now you are getting this message. So let me clear the screen. So if at all you face this issue, sometimes you might be doing different labs, and while login it might take another student ID. It might be using the cache. So whenever you face this issue, you need to perform this action, then you won't get that error again. So let's go back to this. So now let's copy this. You can paste it here. So now the operation is complete. Once that is done, next add the Kubernetes developer role for the cloud build service account. So using export project ID, we are exporting the project ID. Then we are executing gcloud projects, add IAM policy binding to the project. So let's copy this command here, execute it here. Now this is complete. Now you can see updated IAM policy for this project. So it has performed these bindings to this specific project. Next we will run this command, run the following to configure Git in Cloud Shell. Replacing email with your generated lab email address and name with your name. So let's copy this. Here you need to replace the name with your name. And the email address should be the one which is provided in the lab. So here copy this, paste it here. Now it is set. So if you want to verify it again, you can just execute this command git config --- list. So it will show the configuration which we have set it here. So now let's go back to the lab. Next let's create this artifact registry by the name my repository in US East 4 region. So let's head back to Cloud Console. You can type for artifact registry. So click on this. Here click on this plus icon. So the name, so let's copy this. The name should be my repository. And the format will be Docker because we are creating a Docker repository. So here under artifact registry, we are creating a Docker repository by the name my repository in US East 4. So the zone will be US East 4A. So the mode will be standard, region will be US East 4. So you have to select this. So ensure that whatever region you get in your lab, you select that region and zone. Next, the encryption, I will keep it as Google Manage Encryption key only. Rest of the thing, whatever default option it has been enabled, I will leave it as is. Next, let's click on create. Now the repository is created. You can see this. You can also create this repository from the Cloud Shell, from the command line interface as well. Now let's create a GKE standard cluster with this hello-cluster name. So I'll just copy this. Let's go back. Click on Kubernetes engine. Here click on clusters. So here you can see there are no clusters created yet. Here click on create. See here they have mentioned create a GKE standard cluster. So when we head back here you can see this is an autopilot cluster. So when we click on that create button, it is providing us this one, create an autopilot cluster. But the ask is to create a standard cluster. So to do that, you have to click on this switch to standard cluster. So switch from autopilot to standard. So these autopilot clusters are used for production workload and to make use of Kubernetes, most of the features like security, scalability and cost optimization. So this autopilot is most commonly used for production workloads. Since this is a lab, so we will be selecting the standard cluster. So click on switch to standard cluster. And the name, we just provide that name, Hello cluster. And the zone should be US East 4A. So here under location type, you have to select the zonal and it will be US East 4A. So under drop down, you can select the zones. So whatever zones you get in your lab, ensure that you select that only. So here for me it is US East 4-A. This is the zone. So I'll be selecting that. Next, release channel. So let's check the release channel. So it is a regular. Cluster version will be 1.29 or the newer version. Autoscaler needs to be enabled. Number of nodes should be 3. Minimum nodes 2. Maximum nodes it should be 6. So let's go here. So target release channel will be regular. So these are the other release channels which are available. So we'll be selecting the regular one. And the target version, so this is a default version. You can go for the newest version as well. So I'll be selecting the default version only. 1.29 seems not available here, so we'll be selecting the version which is already available. So under node pool details, number of nodes 3. Once you provide the number of nodes as 3 here, you need to click on enable cluster autoscaler. So here under size limits type, so here under minimum number of nodes we will give 2 and the maximum number of nodes will be 6. So once you update this minimum and maximum number of nodes, you can click on create. Rest of the configuration, whatever it is, we will leave the default as is. So now you can click on create. It will create a cluster. So here you can see it's creating a cluster. So you can also execute this complete cluster creation command from the command line interface. So I just want to show how you can do it from the console. So this will make you understand the process in a better way. So if you click on this bell icon, you can see it's creating this Kubernetes cluster. So when you click on this bell icon and when you click on this show more activity details, it will take you to the log explorer to show what is happening in the backend. So it is still loading here. So you can maximize this. So here you can see what all actions happening in the backend. If there is some issue while creating in a cluster, you can come back here in the log explorer and you can debug that issue. So this is how you debug as well. So let's go back to our cluster page. Now the cluster is created. So under status, if you get this green check mark, that means cluster is created. So let's go back here. Now let's create the prod and dev namespace on the cluster. So here, in order to create a namespace on the cluster, first we need to connect to that cluster. So here I will go back to my notepad here. Need to execute this command gcloud container clusters get credentials and the cluster name. Cluster name is hello cluster and the zone in which the cluster exists and the project name followed by the project name. So copy this command. So it will fetch the cluster endpoint and it will update the kubeconfig entry here. So once this is done, we'll create a dev and prod namespace. So if you don't execute this command and if you try to create a namespace directly, this will fail because this Cloud Shell is local. You need to connect to the cluster. You have to execute this command. Then only you will be able to create the namespace on the cluster. So let me execute this command kubectl create namespace dev prod. So you should get this message, created message. So if you want to list the namespace, you can execute this command kubectl get namespaces. So when you execute this kubectl get namespace, you can find all the namespaces which are created on the cluster. We have created the custom namespace dev and prod, so rest of this are already existing one. These namespace are used for different purpose. So let's clear this. Let's go back here. You can click on check my progress and this should be complete now. So this is complete. Let's proceed with the task 2. Create a repository in cloud source repository. So in this task we will be creating a sample app repository. Here search for source repositories. So if you can type your source repositories. So here you will get this. So click on this source repositories here. So here you can find there are no repositories for this project. So now we need to create a repository here. Click on create new repository. Continue. So here we need to provide the repository name and the project ID. So let's go back here. So the repository name will be sample app and the project ID will be this. So you can find your project ID, you can find here, you can copy and paste there. Okay. See, the repository names may contain only alphanumeric characters. So when you're copying and pasting here, sometimes the space also gets copied. So you have to ensure that you remove that space. Now see, you won't get that error message, warning message. Click on create. This is an empty repository. To clone our repository to local, we need to perform few steps here. Here click on cloud console. It will open a cloud console. So we have to perform this operation in the shell. We will copy this command. This command is used to clone this repository into the local. So here by executing gcloud source repos clone and the repository name we are giving and the project ID. You appear to have cloned an empty repository. So this is an empty repository. It doesn't contain any files or directory inside that. We have just created an empty repository and we have cloned that repository into this path. So this is my student path. So here we have cloned that repository. So if we execute ls, it will show the sample app. So this is the git repository which we have cloned it. So once that is done, we have cloned this sample app into the cloud shell. Once that is done, we have to execute this command. Use the following command to copy the sample code into your sample app directory. So for that, you can copy this present working directory. So you are outside the repository. So let me execute that command. So it's copying the sample code into our repository. Now if I go inside the repository, now I can find all the files here. So if you execute ls-ltr, you can find the details about this. So let me clear this screen. So if you execute git status command here, you can see all these are untracked files. This is not yet added. So you need to add these files by executing the command git add dot. So when you provide dot, it will add all the files. So again, when you execute this git status, here you can see now the changes. These files are added and this needs to be committed. So it's still not on the local repository. We have not committed these changes yet. So we have to commit it. So let me commit this before that. Before committing the changes, we have to execute this set of commands. So we will be exporting our region and zone inside this file. So here we can find these files, right? So when we cat this cloud build dev.yaml, so here we can find a placeholder by the name your region, right? So this we need to replace it. Cloud SDK compute region, your zone region. So this we need to replace it, right? That's why we have to execute this command export region with the region and the zone, and the file name we are passing it here for file in sample app. So this file and two files. So let's copy this here. To check if this worked or not, you can cat that file again. Cloud build -dev is the one which we checked. So now you can see this is replaced. Zone and the region, it got replaced with a value which we just passed it, right? So we can clear this now. Now again you run git status. Now you have to be inside that repository for that. Now you again run the git status. So we have modified this file again, right? So we have to add these files again. Now if you run git status, all these files are added now. Next we need to commit these changes. So once this is done, make your first commit with a sample code, add it to your sample app directory and push the changes to the master branch. So once that is done, once this is done, need to execute git commit and add message here, adding the sample code to repo. Now we have committed the changes. Next we need to execute this command git push origin master. Before that, let me take you to the repo here. See, even if I refresh this as well, when I refresh this repository, it is still an empty repository, right? It is still an empty repository. It is not having any branch as well. Okay, so we are performing this operation now. Git push -u origin master. So here git push origin master. So now it has committed all the changes to the remote repo. Refresh this browser. Now you can see all these files got committed. Here you can see this is the ID, commit ID. When it was committed, the message you can see adding the sample code to repo. So all these files and directories are brought into this repository now. Now you can see the master branch. So there is only one branch by the name master. Now next we need to create a branch named dev. Make a commit with a sample code, add it to your sample app directory and push the changes to the dev branch. So if you execute git status, there won't be anything to add here because we have already pushed the changes to master branch. Now let's execute git branch -a. So here you can see only the master branch. One is the local, one is the remote, right? Let me clear the screen. Next we need to create a dev branch. So here to do that, you can execute this command git checkcode -b dev. Switch to a new branch. Now we don't have any changes to be committed. We'll just push this branch to the remote. So to do that, we'll be executing this command git push origin dev. So new branch is created now. So if we go back here, refresh the browser here. So here when you click on this branch, you can find the dev branch as well. So we have just pushed this dev branch now. So you can select that branch as well. So you can select that dev branch. Here you can find the same files and directories which were committed to the master branch. Now let's go back. So you can click on check my progress. So this is complete now. Now let's proceed with task 3, create the cloud build triggers. So in this section we will be creating 2 cloud build triggers. The first trigger listens for changes on the master branch and builds a Docker image of the application, pushes it to the Google artifact registry and deploys the latest version of the image to the prod namespace in the GK cluster. And the second trigger listens for changes on the dev branch and build a Docker image of the application and push it to Google artifact registry and deploy the latest version of the image to the dev namespace in your GK cluster. Whenever there are any changes made on the master branch, a build gets triggered and the changes are pushed to the artifact registry and then it deploys the latest version of the image to the prod namespace on the cluster. And the second trigger will listen when there are any changes made on the dev branch. It will build the Docker image of the application, and then it will push the changes to the Google artifact registry, and then it deploys the latest version of image to the dev namespace. So now let's create this build trigger. Let's go back here. See, you can navigate from here as well. So if you click here, this is a cloud source repository, right? If you click on the settings here, so here you can click on cloud build triggers. So this will take you to that page. So you can click here. So this will take you to the cloud build trigger page. Since we will be triggering the cloud build, this is how it's configured with the repository. So here click on create trigger. Okay, here we need to provide a name to the trigger. Here create a cloud build trigger named sample app. So copy this and come back here. Push to a event will be pushed to a branch. Source repository will be sample app. Branch will be master. Cloud build configuration file will be cloudbuild.yaml. So here region will be US East 1. Since we have created resources in US East 1, I will be selecting US East 1. Under event, you will be selecting the push to a branch. So whenever there are any changes push to the branch, this event should get triggered. Next, under source first gen, click on repository, select this repository, and the branch will be master. So if you remove this, see, you can find all the branches, existing branches. So here select master, and here under configuration, cloud build configuration file, YAML or JSON, right? So if you click here, if you click on this, you have to provide that YAML file name. If you click on Docker file, you have to provide the Docker file directory name. So this is how it gets changed, right? So see, here we will be referring to the cloud build configuration YAML file here. So this is already there. This is the one, cloud build.yaml. It has to refer to this configuration. Okay, once that is done, service account. Under service account, we'll be using this service account. Apps, click on create. Next, let's click on create trigger and create the second trigger here. The second trigger name will be this, sample app dev deploy. Okay, region will be US East 1, and then push to a branch first gen repository, select this, and the branch here you need to select dev branch. So this is the second trigger for the dev branch, right? So you have to select dev. Next, under cloud build configuration, you have to provide this YAML file name. So copy this here, paste. This is the correct file for this trigger. Click on create. So now both the triggers have been created. We have enabled this trigger. So here you can find this is for prod, and it is using this build configuration file, and for dev it is using this build configuration file. Okay, once this is done, after setting up the triggers, any changes to the branches trigger the corresponding cloud build pipeline, which builds and deploy the application as specified in the cloud build.yaml files. So whatever we have specified in cloud build.yaml file, it gets built accordingly. Now you can click on check my progress. So this should be complete now. Okay, now this is complete. Let's move on with the task 4, deploy the first versions of the application. So in this section, we will build the first version of the production application and the development application. First, let's build the development deployment. So for this, let's go back to your console, open your Cloud Shell, ls. Let's check on which branch we are in. We are on dev branch, right? So here what we need to do is we need to inspect the cloud build.-dev.yaml file. So let's vi that file, cloud build-dev.yaml. On lines 9 and 13, we have to replace the version with v1.0. Click on escape set number. So when you execute this, it will show the line numbers here. So on line 9 and 13, right? So here we have to replace the version. So this one you need to replace. Click on insert, click on eye icon, it will take you to the insert mode. So here it should be v1.0, v1.0. Next on a line 13 as well, v1.0. Okay, we have made the changes now. So if you cat this file again, so here you can see our changes are visible. Next we need to navigate to the dev deployment.yaml file and update a to-do on line 17 with the correct container image name. Also replace the project ID variable with the actual project ID in the container image name. Make sure you have same container image name in the dev deployment.yaml and cloudbuild-dev.yaml file. So for that, let's go back here, ls, let's check what's the container image name here, cloudbuild-dev.yaml. So here you can find the Docker container image name. So this one we have to update it in that file as well. So ls, you have to cd to dev. So if we do pwd, we are inside the dev. So vi deployment.yaml here, under image name we have to paste that. Okay, here project ID we need to replace it. Replace the project ID variable with the actual project. So copy this project ID here. Save this. Once this is done, make a commit with your changes on the dev branch and push changes to trigger the sample app dev deploy build job. Once this is done, let's execute git status. Let's verify on which branch we are on by executing git branch -a. So this star indicates we are on the dev branch. Let's run git add dot. So now both the files have been added. Let's commit this. It's by executing the command git commit. Okay, you can find now this is committed. Next we need to push these changes to the dev branch. Git push origin dev. Okay, now the changes are pushed. So you have to navigate to the cloud build and check the dashboard. So now we can see there is one build executed. This got triggered. So you can click on view history, build history. So if you can click on this build. So you can find the build summary here. So sample app dev deploy is the trigger and this build is successful now. So you can find all the details here. So the repo name and the branch name and what build config path, which file it is referring to, everything you can find it over here. So now this is successful. Verify build executed successfully in Cloud Build history page and verify the development deployment application was deployed onto the dev namespace of the cluster. So to verify that, let's go back here and click on this. Let's go to Kubernetes engine cluster. Click on workloads here. See, you can find this development deployment, it is successful. Okay, status it is showing. The namespace is dev. So this is how you verify it. Next we need to expose the development deployment to a load balancer service name dev deployment service on port 8080 and set the target port of the container to the one specified in the Docker file. So here ls cat docker file. So here under docker file we have specified this port 8080, so that we have to set it. So let's execute this command. kubectl expose deployment name and the namespace, the service hyphen type load balancer and the port. So here we have to specify like this. So let's copy this command, go back to console, execute it here. So now this is exposed, you should get this message. So by executing this command, we'll get the external IP address of the load balancer. Let's wait for this command to complete. So now you can find this external IP of this load balancer. Next, navigate to the load balancer IP of the service and add the /blue entry point at the end of the URL to verify the application is up and running. It should resemble something like following. So like this, we should execute. So here we'll take this IP address and you have to provide it like this way. You should get this output. Next, build the first production deployment. Switch to the master branch. Inspect the cloudbuild.yaml file located in the sample app directory to see the steps in the build process. In cloudbuild.yaml file, replace the version lines 11 and 16 with the v1.0. Navigate to the prod deployment.yaml file and update the to-do on line 17 with the correct container image name. Also replace the project ID variable with actual project ID in the container image name. So we have to repeat the steps again for production. So here, so first you need to check on which branch you are. Git branch -a. Can execute command git checkout master. Now we have switched to the master branch. So we have to vi to cloudbuild.yaml. So for master branch, this is the file we are using. So now I have set it. Save this file. Let's copy this. This is the image name. Next we need to cd to prod. Here we have to make changes to this deployment.yaml file. So here on line 17, we have to update the to-do on line 17 with the correct container image name and also replace the project ID. So let's go back here on line 17, right? So the container name will be production container here. So whatever we have copied into the notepad. So this project ID, let's replace the project ID here only with this. This is the project ID. I have copied this project ID here. Okay, ensure that you replace the project ID with the correct one. Copy this, come back here, paste it here. Okay, so only that change we need to make. Next we need to make a commit with your changes to master branch and push changes to trigger the sample app prod deploy build job. Again we need to perform the same steps. So let's go here. Now you can again check the git status. Next you can do git add dot, all the files will be added. Next we need to commit these changes. Git commit -m modified the YAML files for prod. Okay, once this is done, you can perform this git push origin master. Since we are pushing the changes to master branch, we have to specify that. Now this is complete. So under cloud build dashboard, you can see the build got triggered. So now you can see the second build is triggered, running. It is still in running. Sample app prod deploy. So now this is successful. You can see the pass and fail right here. So it is 100% successful. So if you click on this, you can see the build history, how it got triggered and all. Same way, that push event triggered this. So this is a trigger, sample app prod deploy. So this trigger initiated this build and this build is successful. So here under Kubernetes engine, I'm under a Kubernetes engine workload page. So this is the workload, Kubernetes engine workload page. We have to verify this as well, right? So there are and there is another production deployment. So this is successful now. So this deployment is successful. So we have successfully deployed on both dev and the production environment. So this should be in a OK state. Now let's come back. Next we need to expose the production deployment on the prod namespace to a load balancer. It's service name prod deployment service on port 8080. So for that, so we are exposing kubectl expose and the deployment name production deployment, and the namespace we are providing it as prod, the service name prod deployment service, load balancer, ports we are specifying it here. So let's execute it here. Now the service got exposed. Next we need to execute this command kubectl get service prod deployment service namespace is equal to prod. So let's execute this command to get the external IP address of the load balancer. So this is the one. Copy this. You have to type it as. You should get this output. So once that is done, you can click on check my progress and this should be complete now. So now the assessment is complete. Now let's proceed with the task by deploy the second versions of the application. Here we will be building the second version of the production application and the development application. So first let's build the second development deployment. So for that we have to first switch back. So first we need to switch back to the development branch. So let's check on which branch we are. So I am on master branch now. So let me execute git checkout dev. So this will check out the dev branch. Now here in the main.go file, we need to update the main function with this following code. So let's go back here, ls. So cat main.go. So here this is a function which needs to be updated. So let's vi main.go here. Here let's just copy this, update this. So we are adding a handler function for it. Here add the following function inside of the main.go file. So we are adding the red handler function here. So let's copy this entire code, go back here and paste it. So before we had only the blue handler, now we have added the red handler function as well. So let's save this file. Once this is done, we need to change the cloud build -dev.yaml file and deployment.yaml file to the new version v2.0. So let's do that. ls vi cloud build -dev. Here update it to v2.0. In line number 9 and 13 we need to update it. Okay, once done, save this. So here we have updated line number 9. Here we have updated it to version 2.0, and on line 13 as well we have updated this. Once done, save this file. Next cd to dev ls vi this deployment.yaml. Here as well, here we will update this. So we have changed from 1.0 to v2.0. Save this file. Once done, execute git status. So here we have modified 3 files here. In main.go we have added the function, we have added the red handler function. In deployment.yaml and cloudbuild.yaml we have changed the version to 2.0. So now let's add this file, and commit this. Let's execute git push origin dev. So we are on the dev branch. So we have made the changes on the dev branch and pushing the changes to the dev branch. So as soon as we push this to the repository, that push event will trigger. So we have already set the 2 triggers, right? So this trigger will start that build. So in dashboard, if you go to dashboard, you can see in build is executed. So this is running now. You can click on build history. So this is the second build. So the first build is with version 1.0 and the second is having 2.0 version. Now this is successful. I'll open this in new tab. Click on workloads. So under workloads we can find this. So there are 2 deployments made: development deployment, production deployment. So let's go to development deployment, and here click on revision history. So here you can see the revision history for this. So the first revision contained this image with tag v1.0 and now it is having the v2.0. So this is how you verify it. Execute this command kubectl get service name and the namespace. So here you will get the external IP address. Copy this external IP address in a browser. Here you have to give red. So you should get this output. In version 2 we are having this red block. In version 1 we had blue block. Now let's go back. Next let's build the second production deployment. So in order to do that we need to switch back to the master branch. So git checkout master. So this will switch to the master branch. Now ls here vi main.go. So again, and here under main function we have to add that red function handler. Just copy this line, go back here. Next, come to the bottom of this. Here you need to add this following function. Copy this here. So we have added the red handler function in this as well. So save this file. Next, vi cloud build.yaml. So here again we are changing the version. Okay, so now let's save this. Again cd to prod. Here under deployment.yaml as well you need to modify this version to 2.0. Okay, once done, so you have to be in this path. So we have all these files modified. Let's add all of these files. Let's commit this. Okay, once done, let me clear the screen. So once that is done, we need to push the changes to master branch. Git push origin master. Remember, we are doing the production deployment now, so we have to use the master branch. Now this is complete, so let's go back here. So this is the Kubernetes engine workload page. Okay, if you click on production deployment, click on revision history. So we are having one revision, so let's go to build history. The build should be complete for that deployment to be successful. So let's go back to dashboard, and you can see this is still running. So this is the production build pipeline. So this build pipeline is still executing. So once this is successful, then only it gets deployed. So the last step is a deployment. So now this is successful. Let's go back here, so you can refresh this page. So now you can see the second revision. So now the second revision is having this latest image within. So this is how you verify it. So once that is done, so let's check that. So when we execute this command, we get the IP address of this load balancer. So this is the prod deployment service. So this is exposed. So let's copy this external IP address, and in a new tab here we'll give like this. You should get this output. Okay, now this is done. So you can click on check my progress, and this should be complete now. Okay, now this is complete. The last task is roll back the production deployment. In this section, you roll back the production deployment to a previous version. Roll back the production deploy to use the v1.0 version of the application. So we can go back to this build page. So we have 4 builds. 4 builds got executed, 2 for dev, 2 for master. This is the first build which got executed, and this is the second build. So what you can do is, so in order to roll back, you can click on this build, the first build which contained version 1.0. You can click on this rebuild. So what it does is, it will use that image with the tag 1.0, and it will deploy that code. So we are rolling back. So this is one way. So now this is successful. So here we can go back to the production deployment and click on refresh. So here you can see the revision 3 got created, and it is using this HelloCloud build v1.0. That is because we have redeployed that code which was having that image v1.0. Go back, navigate to the load balancer IP of the service, and add the red entry point at the end of the URL of the production deployment, and response on the page will be 404. So let's check that. So this is the production one, right? So we can refresh this. So now you should get this 404 page not found, because we have rolled back. So now I will show you the second method in which you can perform the rollback. So using CLI you can do this. So let's copy this command. Let's execute it here. So now the image got updated. So what we did is, we are referring to this container image with this tag v2.0. So now this is updated. If we go back to this production deployment, if we refresh this, so now this is having the revision 4. So now this is having v2.0. So that is the second method in which you can roll back. So again, if we come here and if we refresh this, it should not give this error. So now it is showing the red block here. How do we revert back this? So again, you just have to update it here to 1 version 1.0. Now the deployment image, it got updated. So now this got updated, right? So again one more revision should be created here. So if we refresh this, see now you can find revision 5 and it is having this image v1.0. So again if we go back here and if we refresh this, now we are getting 404 page not found. So this is how you roll back the deployment. So one is via build history. So if you have some 10 to 15 build history and if you find it difficult to figure out which image it is using, in that case you can just use a command line interface and perform the rollback. So that will also work. So you can click on check my progress now and this should be complete. I hope this was useful. I have showed how you can perform this on a console and also on the command line interface. So I'll be attaching this notepad to the GitHub repository. You can refer to this as well as you do the lab. I hope this video was helpful. If you found my video helpful, please like and subscribe to my channel and stay up to date with the latest content on this channel. Thank you all for watching. See you in the next video.